Welcome back, guys. So this is our module 7, and in module 7 we are going to study the transport layer. So the transport layer is also called a socket layer. So in this module we are going to discuss about transport layer goals and the transport layer protocols. The two most famous transport layer protocols that is used worldwide is UDP protocol, which is also called user datagram protocol, and TCP protocol, which is transmission control protocol. So we have studied data link layer, we have studied network layer, now we will study transport layer. So transport layer goals. So after the network layer has verified that packet is not to be forwarded to next hop, that is, the network layer has made a decision that the packet is actually destined to a local machine on which the packet is received and it is not supposed to be forwarded. The packet is destined to itself. Network layer chop off the network layer header, which is actually the IP header in IP protocol, and hands over the remaining packet to upper layer, which is the transport layer of the TCP IP stack. Now, transport layer has two standard protocols which are widely used and widely deployed across the globe. These two protocols are TCP protocol and UDP protocol. So what are actually the function of transport layer? Transport layer function is to identify the correct process or application running above the transport layer to deliver the packet. This is done by the transport layer protocols TCP, UDP, or you can have your own custom protocol running at the transport layer. Now, among the two protocols, that is TCP and UDP, the TCP protocol has more functionality attached to it. It also does the congestion control in the network. That is, whenever the source machine or the destination machines are communicating and whenever there is a lot of traffic on the network and the network gets overwhelmed or the network is busy or the resources on the network are depleting, that state of the network is called congestion. TCP protocol is complex enough that it also encompasses within itself the mechanism of congestion control. TCP protocol also does reliable delivery of the packets to the application. Reliable delivery means the packet may get lost in the network due to one reason or the other, or the packet may get corrupted. The application running TCP protocol or the application which is using TCP protocol for communication can recover from all these network issues like packet loss, packet corruption, or congestion control. So all this functionality is done by TCP protocol. UDP protocol is simple protocol and it is a very simple mechanism of transmitting a packet from source machine to destination machine, and it do not have all these features which TCP has. So we will discuss that in what scenarios it is beneficial to use TCP as a transport layer protocol and in what scenario the application must use UDP as a transport layer protocol for carrying out communication. So transport layer, once again, the overall function of the transport layer protocol is the process to process delivery of the data packet. And again, transport layer is not aware of any layer above it or below it. This is true for every layer in the TCP IP stack, in fact. For example, in the TCP IP stack, the data link layer do not assume that the layer running above it is an IP layer. It could be IPv6 protocol. Right? Similarly, IPv6 protocol do not assume that the protocol running above it in the TCP IP stack is actually the TCP protocol. It could be UDP protocol. So how the layer came to know that the layer running above it or below it is running which protocol? This we will discuss in the next slide when we will be studying the stacking of headers. Now coming back, the data link layer has the responsibility for the transmission of data packet hop by hop. So this is hop by hop. So it is the job of the data link layer to take the packet from machine A to machine B, whereas machine A and machine B are directly connected machines. Network layer, on the other hand, has the responsibility to take the data packet from source machine to destination machine. Now, source machine and the destination machine could be present anywhere in the world, and there can be any number of L3 routers in between the source machine and destination machine. So this is actually internet. So network layer is responsible to take the data packet from source machine to destination machine. And now comes the transport layer. The transport layer has the responsibility to take the data packet from application A running on source machine to application B running on destination machine. That is the reason the transport layer is concerned with process to process delivery, where A is the process running on source machine and B is the process running on destination machine. So you can see that each layer in the TCP IP stack is actually associated with its one particular function, and the function do not overlap at all. All these layers combine together and plays their own specific role for which they have been designed in order to establish end-to-end communication between the application running on source machine with the application running on destination machine. Now, as I said, there are two standard and famous transport layer protocols are UDP protocol, which is called user datagram protocol, and TCP protocol, which is called transmission control protocol. So from the interview perspective, it is often asked that what is the difference between TCP and UDP, what are their use cases, and when should you choose to use TCP as a transport layer protocol, and when you should choose UDP as a transport layer protocol. What are those scenarios in which you will choose TCP or UDP and why? So as I said, TCP is the application. So the application, for those applications which needs reliability, that is those applications which cannot tolerate data packet loss, will prefer to use TCP, because TCP has a mechanism to make up for the packet that are lost in the network for some reason. UDP protocol is used for the application which do not need reliability. That is, if the packet is lost, then it is lost forever. There is no recovery mechanism, or the application do not need a recovery mechanism. In those situations, the application should use UDP protocol. TCP protocol, because it has a lot more functionality attached to it, therefore TCP protocol is slightly slower as compared to UDP protocol. UDP is simpler but fast service. TCP protocol is connection oriented. Connection oriented means if the source machine A is communicating with the destination machine B using TCP protocol, then source machine A will save the state of connection, that is the state of TCP connection. So source machine will save the state of TCP connection with machine B. Machine B also saves the connection state. It saves the state of the connection with machine A. So this is what we mean here by connection oriented protocol. That is, there is some data structures on machine A which will have information that machine A has actually set up a TCP connection with machine B for this much duration, and these many number of packets have already been transferred to machine B using TCP protocol. So all those relevant information will be maintained on machine A. This is called the state of TCP connection. UDP protocol, on the other hand, is connectionless. That is, machine A, when establish a UDP connection with machine B, machine A or machine B will not going to save any state with respect to the UDP connection. Again, TCP protocol have a lot more functionalities. It can recover the lost packets, it can detect the malformed or corrupted packets, TCP react to congestion in the network, and etc. UDP, on the other hand, there is no such mechanism of recovering the lost packets or detecting the corrupted packets or react to the congestion in the network. A packet that is lost or corrupted is gone forever if the application is using UDP as a transport layer protocol. So TCP protocol should be used by the applications which are sensitive towards data loss. For example, if you are sending an email or the document file, and if some bits and bytes or packets of your data is lost, then the machine which is receiving your data will actually have a corrupted document. So this type of data transfer cannot afford any packet loss. That is the reason that TCP should be used in such cases. And in other scenarios where there is audio or video streaming is going on, and in case of audio and video streaming, even if there is some data packet loss in the network, it will marginally affect the quality of audio or video, which you will not even going to detect, or hardly you will going to detect. In such kind of applications where, in such type of scenarios where the applications can actually tolerate some loss of data or packets, preferably uses UDP protocol. So example of such protocols are UDP audio or video streaming applications. So consider TCP and UDP as twins. Both helps achieve the same goal: data delivery from source to destination process, but in a different way. Again, it's an important note. TCP is a complex protocol. Too deep knowledge of its internal functioning is not required from interview perspective. However, it is very much a part of UG syllabus, and hence students are advised to go through congestion control mechanisms of TCP from standard books. So this course is out of the scope with respect to TCP internal functionality.